All right, this is section 3.5 in your textbook, page 145. We're looking at properties of circles. So as I mentioned to you, you guys are going to draw in your notebooks a circle as best you can. If you have a protractor or a compass, you can use two sides of the protractor to make a circle, or use a compass to draw it as accurately as you can. Once you have that circle, we're gonna define first of all what a chord is. A chord is a line segment joining 2 points on a curve. So the first way you can find, first thing we need to do is find the center of the circle. Okay, you can do that if you have a loose piece of paper. You can literally fold the circle on top of itself, so you're folding it directly in half, making sure you look through the paper to make sure the curvature lines up, and then fold it the other direction, and you should get a point in the middle, relatively in the middle. Of course, this is going to be all approximations here on the board for me, so I'm trying to get as close as I can. You can also try and just eyeball the center of your circle. So what properties, first of all, before we start, what property does diameter have? What do I mean when I say the diameter of a circle? Yeah, right here.
The distance from point of a circle crossing through the midpoint of the circle to another point.
Good. So diameter so it's the length So it's the length of a line crossing through the center of the circle to the outside edge. All right, so this would be a diameter. Center of the circle, it's a line crossing through the center, going from one edge to another. This would be a diameter. Doesn't have to be straight up and down or across. Can you just plug that in, please? The cable? The cord? Oh, it is. Sorry. I thought it was. Okay, my mistake. So that's a diameter. We also want to look at what a chord is. So a chord we have defined as a line segment joining 2 points on a curve. So we need to find 2 points. So all of you just take 2 random points on your curve. Okay, and you're going to label them A and B. Point A and point B. Doesn't have to be on the same side even. It could be anywhere. It could be over here, A and B over here. Preferably don't draw a diameter line and label them A and B, because we want to show any 2 points on a curve, not specifically 2 points that are directly opposite each other, which we know now is already the diameter. So just choose 2 points, A and B, anywhere, and join those 2 points together on your piece of paper. Okay, next we want to draw the right bisector to the chord. Okay, so we have to remember what a right bisector is. I think this was Jonathan who told us what a right bisector was. Do you remember now, Jonathan?
Yeah,
Kind of?
I know what it is, but I just don't know how to define it.
Okay.
Is it the slope that is, the line that bisects one line
Yes.
90 degrees?
Excellent, good. So right bisector is the line in Jonathan's words, the line that bisects. So I'm going to put in brackets here in case you're not sure what bisects means. Divides in half. Another line at 90 degrees. Excellent. So, if I wanted to draw the right bisector to the line AB, Sebastian, how would I draw that?
So first you find the midpoint of.
Excellent. Perfect. Yeah, I find the midpoint is going to be around here. So everybody's going to do that. If you have a ruler, then all the better. You can measure and find the midpoint exactly.
And then
I prefer that if you could, but if you don't have time, you can do that. Yeah, and then next, Sebastian.
you just draw the negative reciprocal.
Right, so then you're going to draw the negative reciprocal. So I'm going to use my textbook here, but you guys use a ruler. You want to draw a 90-degree angle. So you're going to line it up on that midpoint. And there's my 90-degree angle. Okay, so this is my right bisector. That's the center of my circle C. That's a 90 degrees. So what do we notice here? Dominic, what did you notice? What did you notice? I drew the right bisector. What did you notice? What is the right bisector? What was interesting about the line I drew?
It lines up with the middle of the circle.
Good. It lines up or it crosses through the middle of the circle. Right. And my hope is that no matter how strange your circles are on the paper in front of you and how weird your chord is, or whatever point you chose as your chord, all of your right bisectors should cross through the middle. You guys finding that?
Yes.
Okay, so that's the first property that we want to list. Okay, so this is one of the key points. Okay, that's one of the main parts of this lesson, is to understand that the right bisector of a chord passes through the center of a circle. Again, what's a chord? Any 2 points on the outside of a circle. Okay. The other key point, which I think is obvious, I didn't mention it, but the diameter I think this is an obvious one. The diameters of the circle intersect at the center of the circle. Can there be more than one diameter? Is there only one diameter? I don't know, because that definition says diameters, so I'm a little confused. Stephen?
They're all equal to the same size, but you can have multiple lines.
Excellent. Very good explanation. So this is a diameter, I said, but this is also a diameter. As long as I'm directly opposite, this is also a diameter. Okay? So just like Stephen said, they all have the same length, but you can have multiple lines showing that what the diameter is exactly. Thank you. All right. Okay, one other thing I want to show you is if you take your piece of paper and you draw 3 points. So randomly anywhere, 3 points. Sorry, actually, you start off with 1 point towards the center. That's what we want to do. 1 point to somewhere in the center of your paper. Okay? You're going to mark 1 point in the center of your paper. Yeah, somewhere towards the center of your blank piece of paper. Then you're going to draw 3 points that are about the same distance from the first point. So any direction, but same distance. So I'm going to use a little bit of a measure here. Let's see what I can find. So I'm just going to measure 3 points, approximately this distance away. It doesn't have to be all the way around. Okay, there's 3 points. Label the points P, Q, and R. So now if we wanted to find the center point, we want to find what the center point is. How can we do that? Yeah?
You have to.
So I'll give you a big hint. It has something to do with what we just learned. Matthew.
Find the slope of PQ and give the negative reciprocal.
Okay, excellent, I like it. So find this slope, find the negative reciprocal, that'll give me what? A line that's perpendicular, right? What else do I need to find though? You're good, you're right, you're on the right track. Where were you gonna go with this?
Y
To find this slope? No.
No, to find the point.
Right here? Oh, this point.
Yeah.
Okay. How? You're close. You're on the right track. Tiago.
Find the bisector P and Q, and then get the midpoint of P and Q, and then you can get the equation of the bisector.
You're close. You guys are close. Keep thinking. Everybody. Steven.
Find the right bisector of PQ, and then you find the right bisector of QR, and then you see where they intersect in order to get the center point.
Excellent. You guys understand that? What he did? So because of this property, the right bisector of a chord, this might as well say any chord, of any chord, passes through the center of the circle. So, Stephen's method, he said, well, let's find the right bisector of PQ. And the way we do that is we first find the midpoint. We just need these two coordinates, right? We can get the midpoint. And then we find the slope and use the negative reciprocal slope. And then we can find out the equation of this line. We can find out exactly what it is. So you'd have an equation for this line, y equals mx plus b. We do the same thing over here. Find the midpoint of QR. Find the right bisector, so the slope, we find the negative reciprocal. We get the equation for this line. We then set these two equations equal to each other. And guess what? We have the center of the circle. Because it's the intersection point between these two, and we know these two lines cross through the center. Does that make sense? Can you guys see how this might be useful? Somebody think of a way that you could see this being useful in the real world. You can think of that. I want you guys to understand this is a pretty interesting. Anybody? So here, I'm going to help you out. Think of these points as, let's say, settlements, okay, or like little towns, okay? Can anyone see how this formula just knowing these 3 points might be useful? Any?
You would know where to put town center.
Okay, good. Or, maybe a command base or a recruiting center, if these are training camps. Okay? You want to put a training camp or a command center in the center between these 3 points. Okay? But you don't know where to build it yet. It's very hard to figure that out without mathematics. If we can know where these points are on a map, we can now, or you guys can now, algebraically find the exact location that is the same distance away from each one of these points. Because you guys understand how that works now, right? Now that we have these 3 points, we can draw a circle that crosses through them, right? That's the idea. Okay, so fairly useful property is knowing that the right bisector of any chord on a circle intersects or passes through the center of the circle. Good. All right, let's look at the example 147, example 1. It says, verify that the center of this circle lies on the right bisector of the chord AB. So, we can see the center of the circle is at 0, 0. We know that from the graph. The graph is accurate enough to show that. So we have a circle here. This is on page 147. So, how can we figure this out? We have a right bisector here we want to check. It says verify that the center of this circle lies on the right bisector of the chord AB. So, we want to check that this point 0, 0 lies on this line. Okay, and we're assuming we're not lazy and we just don't want to look at it and say, yeah, it looks good to me. We want to actually prove it. What would be the first steps we take? Well, besides Stephen and Gianluca. How about Mark? What are you going to do? We want to find out that this point 0, 0 is on this right bisector line.
So you'd have to find the slope of AB.
Okay, yeah, we can find the slope of AB. Good. And then what? What will that give us? Why are we doing that?
Because then you would be able to find the slope of the right bisector.
Good. So you're working on finding the equation of this line? Is that right? Good. Excellent. So if we can find the equation of this line and plug in 0, 0 and it satisfies that equation, then have we proven it? Yes. So the question then becomes, how do we find the equation of this line? So Marcus told us the first thing we want to do is find the slope of this line because the negative reciprocal will give us this slope. Good. So we're going to calculate the slope of BA. All right. So we have the slope of BA is positive 3. So the slope of the right bisector then is going to be negative 1/3. Okay, but I'm not done. How do I get the equation of a line? What are the two pieces of information I need? Ace? Yeah, so the equation of a line, I need what? Two pieces of information. Good, and? Okay, but in grade 10, we don't need the y-intercept, we need?
Any point on the line?
Yeah, any point on the line. So I don't know what the y-intercept of this line. I'm trying to prove that it's 0, but I don't know that. So what point would I use? Yeah, Lucas.
The midpoint?
Good, the midpoint, because we know it's the right bisector. Okay, so we need to find the midpoint then, the midpoint of AB. Okay, and for that we use our midpoint formula. Okay, so now we have the slope of the right bisector, and we have a point that the right bisector contains. So with these two pieces of information, we can plug into our formula y equals mx plus b. Plug in this point. We find out that b is 0, so then we know that our equation becomes y equals negative 1/3 x. Finally, the last step, Gennaro, if I want to know if the point 0, 0 lies on this equation, what do? So I have this equation, right, Gennaro? This equation is representing this line here. I want to find out if 0, 0 is on this line, so what do? Remember, when you have a point, you want to verify that it's on the line?
Thank you.
No? Hey, Julian, you want to help him out?
I just plug in the origin.
Yeah, we're just going to take this value, okay, and plug it in. All right, Julian? Or Gennaro? No problem, right? So 0 is equal to negative 1/3 times 0. It wasn't a trick question. I wasn't trying to put you on the spot there. 0 is equal to 0. Okay? You also could have figured that out from here already, right? We know that's the y-intercept. So if it's the y-intercept, it's actually the point 0, 0. So if you would have realized that as well, you could have stopped there even. Okay? So therefore, we know that the point, the center of the circle, it lies on the right bisector. Any questions? All right, example number 2. So this is on the following page. It says, show that the points P, Q, and R lie on a circle with its center 4, 1. You guys should be writing this down, right? Not talking. Alright, so it asks us to show that the points P, Q, and R lie on a circle with its center 4, 1. So we want to see that these points, we're making sure that they're on the outside. That they're all contained on this circle. So does anyone have any ideas how we could do that, Josh?
Well, if those points are all on the circle in the center,
Yeah.
well, the radius should all be the same.
Excellent. So a definition we haven't actually talked about yet, but excellent. A radius. Radius is what, Josh?
The distance from the center of the circle to any point
Yep.
on the circle.
Distance from center to any point on outside of circle. Okay? So what Josh is saying, well, if all these points are on the same circle, then I know that this line is going to be equal to this line, which will be equal to this line. Okay? So if that's the case, then I just need to use my length formula to check the length of CR, CQ, and CP. Okay, if they're all the same, then yeah, they lie on the same circle with that as its center. All right, so we check the length of CP using our length formula. Check the length of CQ. Using the exact same method, we get the same value. And CR, the same method, we also get root 41. Okay? So because these three lengths are the same, we know then that this point lies in the center of a circle where they all lie on the outside. Those 3 points. Any questions there? B, does any other circle pass through points P, Q, and R? Explain. All right, Andrew. Without using any algebra or any math, what do you think? P, Q, and R.
I don't think so.
Yeah, I don't think so either. Can you think of drawing a circle that would cross through these 3 points any other way? No? All right, let's see what the book says is the answer here. So it says the right bisector of PQ includes all points that are equidistant from P and Q. So the right bisector of PQ. So here's PQ. Here's the right bisector. Right, it's on the midpoint. So this right bisector, remember one of the properties of a right bisector is that it contains all of the points that are equidistant from P and Q. You guys remember that? Equidistance? Okay, so this point is equidistant from PQ. This point is equidistant from PQ. The center point is equidistant from PQ. Does that make sense? Okay. Similarly, the right bisector of QR includes all the points that are equidistant from Q and R. So if this is my Q and R, here's my right bisector. This line now contains all the points that are equidistant from Q and R. You see where I'm getting with this? Okay, these two lines meet only at point 4,1 in the center. There is no other point equidistant from P, Q, and R. And of course, to get a radius, we need to be equidistant. Does that make sense? So this is the only point that is equidistant from P and Q, also equidistant from Q and R. So therefore, those 3 points, this is the only possible center. Therefore, this is the only possible circle. Okay? All right, and that's the last key point, is that there is only one circle There's only one point, or one circle that passes through 3 given collinear points. Any questions? No? Okay, you guys can start your homework.